Imagine a dark forest under the pale glow of moonlight. You hear the rustling of leaves, a chirp of crickets, and the faint flutter of wings. Suddenly, something brushes against your skin. A moth. But this isn't just any moth. This nocturnal wanderer has a sinister secret. It drinks blood. These enigmatic creatures, called vampire moths, may sound like something from a horror story, but they are real and thriving in the natural world. In this documentary, we uncover the bizarre world of blood-sucking moths, explore their biology, trace their evolution, and reveal their surprising connections to some of the most harmless insects in your garden. The vampire moth belongs to the genus Calyptra, a group of moths in the family Arabidae. While most moths feed on nectar, some species of Calyptra have evolved a unique adaptation, the ability to pierce the skin of mammals, including humans, and feed on their blood. These moths are primarily found in parts of Europe, Asia, and Africa, though their range is expanding due to changing climates. What makes them extraordinary is their anatomy. Their proboscis, a long, straw-like mouthpart adapted for sipping nectar, has developed into a powerful needle-like tool. Using small, backward-facing barbs, the moth can pierce the skin and draw blood, a process similar to how mosquitoes feed. How does a moth become a blood feeder? It's a fascinating example of convergent evolution, where unrelated species develop similar traits to exploit a particular resource. Vampire moths are thought to have evolved from fruit-piercing moths, which use their proboscis to break into tough fruit skins. Over time, some species adapted to pierce the skin of animals instead of fruits, seeking the nutrient-rich resource of blood. Blood provides essential nutrients like proteins and iron, which are especially useful for female moths during reproduction. However, feeding on blood isn't easy. Vampire moths must secrete anticoagulants to keep the blood flowing and use specialized sensory receptors to locate blood vessels beneath the skin. One of the most chilling aspects of vampire moths is their occasional encounters with humans. In regions where these moths are found, people have reported strange sensations during sleep, only to wake up with tiny puncture wounds. Although these bites are not harmful and rarely cause infection, they can be unsettling. Interestingly, the behavior of these moths might hold scientific value. Studying their feeding mechanisms could help researchers develop better tools for blood sampling or treatments for insect-borne diseases. Despite their macabre feeding habits, vampire moths play an essential role in their ecosystems. Like other moths, they are pollinators, aiding in plant reproduction. Their larvae contribute to soil aeration by feeding on and breaking down plant matter. Furthermore, they are prey for birds, bats, and other nocturnal predators, maintaining the balance of the food web. Their blood-feeding behavior also highlights the incredible diversity of nature, showing how species can adapt to fill unique ecological niches. As climates change and habitats are altered, the range of vampire moths may expand. Already, species once confined to Southeast Asia have been spotted as far as Europe. This expansion raises questions about how these moths will interact with new ecosystems and species. Will vampire moths become a common sight in more parts of the world? Could they pose a threat to livestock or humans? Scientists are keeping a close eye on their movements to understand the implications of their spread. Throughout history, blood-drinking creatures have captured human imagination, from vampires to chupacabras. Could vampire moths have inspired any of these tales? While there's no direct evidence, it's fascinating to speculate how encounters with these moths might have fueled folklore in regions where they are found. The vampire moth challenges our perceptions of nature. It's a reminder that the world is full of surprises, and that even the most unassuming creatures can have extraordinary adaptations. By studying these moths, we not only learn more about evolution and biology, but also gain a deeper appreciation for the complexity of life on Earth. As you close your windows tonight, remember, not all vampires have fangs. Some have wings and flutter in the moonlight, quietly rewriting the rules of nature.